he buys 3 slides. Good. And we also have the supply function. So the demand function is 0.425x squared minus 5.7x plus 22.5 and 0.3x plus 5.3. Perfect. So we're looking at the producer. So first of all, she wants the consumer surplus at 3 and the producer surplus at 3, and then the equilibrium, and then again. Okay, perfect. So for x equals 3, first of all, we have to find d of 3 because we need a point. This is not the equilibrium point. This is not obtained from d of x equals c of x. S of x. So the point in this case is 3 for the demand function, 3 comma d of 3. And when we get to the supply function, there is a different point, 3 comma s of 3. They're not the same point. This one will be for the demand and this one will be for the supply. So I'm going to punch this in and plug in 3 and punch this in and plug in 3 and see what I get. So in the graphing calculator, here it is, in y equals, clear anything and everything you have, 0.425x squared minus 5.7x and plus 22.5 and 0.3x and plus 5.3. And you will see these are not the same. This is not the equilibrium point. So when I plug in 3, I will get 2 different numbers. Okay, so the first point is 3 comma 9.225, and the other point for the other function is 3 comma 6.2. Okay. So now the consumer surplus is the integral from 0 to 3 from this function, but minus this product, 3 times 9.225. The producer surplus is this product, 3 times 6.2, minus the integral from 0 to 3 from the supply function. Now, I'm going to plug this in the graphing calculator and this in the graphing calculator just for the purpose of not wasting too much time on this and integrating a quadratic function or a linear function. So in the interest of time, so we can do more than just that. So I'm going to go to math and I'm going to use number 9, and the integral is from 0 to 3 from d of x, which is 0.42. Yeah, will it allow me to do that? Let me just 1 second. I'm just curious. Look at that. Very nice. So 3 times 6.2 minus from 0 to 3. But now the variable is the second one. Of course, dx. Wonderful. Okay, so it's $18 for the first one and 1.35 for the second one. Now they're asking us, fine. So if she pays for 3 slides, she's getting an extra a bonus if you want. Not money in her hand, but I don't know, excitement, happiness, whatever you want to call it, in the value of $18. Also, the producer surplus, if she pays and gets the excitement out of 3 slides, they also enjoy not money in their hand, but they enjoy an extra of 1.35. Now, the problem is also asking us to find the equilibrium point. Well, the equilibrium point requires us to solve this equation. And that equation is 0.425x squared minus 5.7x plus 22.5 minus 0.3x and minus 5.3 equals 0. So I have to solve this equation first. So 0.425x squared, this with this is minus 6x, and this with this is positive 17.2. Am I correct? Yes. Of course, I'm not going to solve this by hand. I'm going to use the feature called poly because it's a polynomial. And this is number 9. It's quadratic. Yes, yes, yes. 0.425 is the first coefficient. The second one is negative 6. And the last one is 17.2. Oops, not 0. 17.2. And yes, so x, very nice, x equals 4 slides, and x equals 10.11 or 10.12. But the problem is telling us not more than 6. So although this is a correct solution, we will not consider that. So the equilibrium point is 4 comma either one. It doesn't matter. So I plug in 4. And when I plug in 4, 6.5. See how valuable it is to have the functions in y equals and be able to immediately determine what I need. So then the consumer surplus is the integral from 0 to 4 of the demand function dx minus this product, 4 multiplied by 6.5. And the producer surplus is the other way around, and also from a different function. So the producer surplus is this product. This time, these two are the same because we're talking about the equilibrium point. But for 3 slides, they are not the same. So the integral from 0 to 4 from the other function, which is the supply function, dx. So I'm going to go back and see if I can fool it. Can I fool it? I think I can. Okay. So this is 4. This is 6.5. And this is 4. Wonderful. Boom. 2.4. Now I have to go back to the previous one. Not this one. Not this one. Yes, this one. Where I have up here 4. Where I have here 4. And I have here 6.5. That's it. Boom. 27.47. Any questions? Any questions on this problem? Any questions? Okay, anything from chapter 6? Anything from chapter 6? Derivatives, the d-test, linear regression.
Can we do a d-test problem?
Yes. Those are on page, we can choose from page 576. Yes, we are ready. Any preference?
We do 8.
Yes, 8. Very good. So f of x comma y, x squared plus y squared minus 4x plus 2y and minus 5. Good. If you remember, we need to determine fx and fy and set them equal to 0 and create a system. From this system, we get a point or points. So, first of all, fx, 2x minus 4, fy, 2y plus 2. Now I create the system by setting those equal to 0. So 2x equals 4 and 2x equal to y equals negative 2. So x equals 2 and y equals negative 1. So the point we obtain is 2 comma negative 1. Now we have to find fxx, fyy, and fxy. Why? Because the d, or the d number, requires fxx at this point times fyy at this point, 2 comma negative 1, minus the squared fxy at this point. Okay, but it's nice because fxx is just 2, fyy is just 2, and fxy is 0. So 2 times 2 minus 0. So this is 4, which is a number greater than 0. So d is greater than 0, which is good. We want that. And also fxx is greater than 0, which means a relative min. If d is positive but fxx is negative, it means relative max. What is the relative min? I don't know. I have to plug it in. So in the function, I have to replace x by 2 and y by negative 1. So f of 2 comma negative 1 is 4 plus 1 minus 8 minus 2 minus 5. So this with these two, so it's negative 10. So this function f of x comma y at the point 2 comma negative 1 has a relative minimum. How much is the minimum? Negative 10. Good. A tangent, average value, limits, differentiation, marginal cost, marginal revenue, marginal anything. It's a derivative, graphing, approximate the area, consumer surplus, producer surplus, um, differential equations, relative max min. That's all I can think of. So just remind me, and I will not forget, once I say remind me, I always remember, um, to look at a couple of examples with finding the area enclosed between graphs or among graphs. We did that. So upper minus lower. Is there anything else that you wanted to look at? Any topic, anything?